Once again, the key thing here is to keep pairing off to the right hand side. Okay. So now that we've done all sets, that's the 7, 9 is done. What about the 7, 3? Well, 7, 3 is here. There's nothing to pair off to the right, so that's done. What about the 9, 3 as a set of size 2 to convert to a sets of size 3? Well, the 9, 3 has nothing to the right hand side, so that is done. So we've exhausted all sets of size 3. And then finally, sets of size 4 is the set C itself, which gives us the values 2, 7, 9, and 3. Okay. So that's how you construct the power set, especially when you have a finite set of elements. Yeah, it's a little bit more complicated to construct. Well, a lot more complicated when the set is a lot larger. Yeah, okay, and especially if the set is even infinite. Yeah, okay. But when it's finite, this particular technique works perfectly fine. Another question that we could ask is, well, what is the cardinality? What is the cardinality? Okay, of the power set of a set A. Okay. Well, let's have a look at what we've done previously. Okay. Okay, we can actually see that the power set of A, when A had cardinality 2, the power set of A. So let's actually keep an eye on this. Yeah. Okay. Let me actually just maybe what I'll do is I'll just move this page here again. Okay. And let's consider our sets. Our original sets, okay? Our original sets and the cardinality of their power sets, okay? Let's consider the cardinality of the original set and the cardinality of the power sets that we've constructed, okay? So the first set that we had was A, which is of size 2, so its cardinality was 2. The size of its power set was 1, 2, 3, it was 4, okay? The next set that we had was of size 3, 1, 2, 3. Its cardinality, the cardinality of its power set was, how many elements are in its power set? It was 1, 2, 3, 4, 5, 6, 7. There was 8 elements in its power set. So there was 8. And then the final one that we did was a set of cardinality of size 4. The size of its power set was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It was 16. Okay? And hopefully we can actually see a pattern. Actually, let's consider one of the other base cases. Let's consider a set of size 1, okay? So let's say for argument's sake that we have a set A, B, C, D, let's say E, and the set just contains the element 2, right? Well, its power set, okay, is the set of all possible subsets. So the smallest subset is the empty set. And then the singletons, well, there's only one possible singleton, which is a 2, and there we go, we get the power set. So actually what we have now is that a set of size 1 has a cardinality of 2. So a set of size 1 has a I'll actually just put this out here, has a cardinality of 2. And hopefully we can actually see the pattern. When size of A is 1, it's 2. When it's 2, it's 4. When it's 3, it's 8. When it's 4, it's 16. And we have actually a well-defined sequence here. But more importantly, here's the rule. You can actually see we're going 2, 4, 8, 16. Okay? Which is the cardinality by definition of the power set of a set A, okay, is equal to 2 to the power of the cardinality of the set that we're constructing the power set on. So actually, in this case here, we have the cardinality of the power set for A. If A has cardinality 2, it's 2 to the power of 2, which is equal to 4. If A has cardinality 3, it's 2 to the power of 3, which actually is equal to 8. And if it has cardinality 4, well then the power set's cardinality is 2 to the power of 4, okay, which is equal to 16. If it has cardinality 1, well it's 2 to the power of 1, 2 to the power of 1, which is actually equal to 2. Okay? Maybe a question that you could actually ask is, what is the power set of the empty set? Okay. Well, let's think about that here. Okay, what's the power set of the empty set? Okay, maybe we'll do that. That's an interesting one, yeah. Okay, what's the power set? So let's A, B, C, D, E. Let's say let F equal the empty set. Okay, actually we actually have a symbol for that. It looks like this. Okay, and the question is, what is the cardinality? Okay, of the empty set, of the power set of the empty set. Okay, well, the empty set has cardinality 0. The rule says it's 2 to the power of the cardinality of the set. So it's 2 to the power of 0, which is equal to 1. So what does that set look like? What does the power set of the empty set look like? Well, it's a set, and it contains all possible subsets. Well, the smallest possible subset that you could have is an empty set. Okay, so there's no other subset that we could have that's a subset of the empty set, because any other subset will have cardinality greater than 0. And in other words, it will have an element, but that element will not be an element of the empty set, in which case it will not be a subset. Okay, so actually we can actually see here that the power set of the empty set is a set that contains an empty set. There's an unusual thing there, yeah. But it's actually nice, and it's actually a good old rule, yeah. But anyway, guys, this is Jonathan Lambert once again with the Mathematics Development and Support Service at the National College of Ireland. And this video, another video in our series on set theory, introduced you to the concept of what the power set is. So once again, guys, I hope this video was some way intuitive, and more importantly, I hope it was helpful for you. And thanks for watching.